Okay. Melanson, his Waterworks Association. So I'm going to start that again. I'm sorry. So tonight we welcome online Todd Melanson, Environmental Compliance Manager for the Chelmsford Water District, to discuss Chelmsford water and the latest findings regarding perfluorooctanoic acid, PFAS levels. Todd Melanson holds a Bachelor's of Science in Biology with a minor in chemistry from North Adams State College. He has worked as a microbiologist and analytical chemist in water labs for 17 years and as environmental compliance manager for the Chelmsford Water District since 2007. Melanson is also the president of the Worcester Middlesex County Waterworks Association, a member of the Massachusetts, the New England, and the American Waterworks Associations, and his major accomplishments include leading on the CWD solar array at Crooked Spring WTP, which was the first and at the time the largest municipally owned ground-mounted solar array in New England. His Waterworks Association committee memberships include NEWWA, the Water Conservation, Water Resources, Residual Committees, and he was part of the steering committee for the MassDEP Water Waste Alert Response Network. He was also a member of Laboratory Advisory and Technical Committees at the NWWA. Todd is a U.S. Army and Massachusetts Army National Guard veteran, having served from 1985 to 1996. What you will find out in this presentation, you will find out about the Chelmsford Water District, who is part of the district and what locations are under PFAS 6 advisement. You will also learn about the Mass Environmental Protection Agency, Department of Environmental Protection, and their regulations around PFAS. What is PFAS and what everyday items can be found in it, and how can we limit exposure, and how is it affecting district and what we are doing to address the issue, including resources, plans, and support. And so with that, sorry for that stalled beginning there, but again, please submit your questions to the chat to be asked after the presentation, and I will hand it over to Todd. Thank you so much for joining us tonight.
Well, Jessica, thank you. Thank you for the opportunity. Thank the residents for attending. My name's Todd Melanson, and as Jessica said, I'm the Environmental Compliance Manager for the Chelmsford Water District. PFAS 6 is the regulation of MassDEP and their polyfluorinated alkaline substances. And Massachusetts regulates 6 of them. So to start this off, the Chelmsford Water District, or CWD. We were founded in 1913 as a water district. Locally, we have the nickname of Center, but our name is the Chelmsford Water District. The northern boundary of the district runs right along Route 3 in and around Drum Hill Rotary, Meadowbrook, and Richardson Roads, just to give you an idea. The eastern boundary runs right along Route 129 and River Neck Road. So anything east of that in Route 3 is outside of us and is East Chelmsford. Anything above Drum Hill and Meadowbrook Roads is the North Chelmsford Water District. The district itself is split in half by 2 pressure zones and by a watershed division. On the left-hand side is of the system is primarily supplied by the Crooked Spring Water Treatment Plant, and the right-hand side is primarily supplied or is supplied by the River Neck Road Treatment Plant and their associated wells. Chelmsford Water District draws its wells, water from wells. We're all groundwater, but they're in 2 different watersheds, or what are called basins. Crooked Spring draws its water, the wells draw their water from the Merrimack River Basin, and River Neck Water Treatment Plant draws its water from the Concord River Basin. We do have a 3rd treatment plant, a very smaller one at Smith Street, and it is our emergency and seasonal backup plant. It usually comes on in about April and shuts off October, November, and it helps us manage the summer demand. And that's in the Merrimack Basin. The separation's due to pressure differences in the 2 systems. Crooked Spring comes out of the plant at about 120 PSI, whereas River Neck comes out at about 90. And why that's important for you to know and why the division is needed is we pull water out of the ground out of what is called the Water Management Act. And that sets limitations based on the watershed. So every community is given a certain allotment, and that is called your registered volume. And you're not supposed to exceed that limit on an annual basis, on an annual average basis. And so you kind of have to average those out, and we kind of have, and because the pressures are so much higher on the Crooked Spring side, it would eventually take over more of the River Neck side, and we would be out of balance. While every source in the Chelmsford Water District has a measure of PFAS in it, the compounds detected, Crooked Spring is the only one that has had a violation. But it was only for the third quarter. Since then, it has returned to below the MCL. So for the fourth quarter of 2021, the first quarter of 2022, and as recently as this month, we are well below the 20 MCL. And we'll get into the actual MCL in a little bit. So on the map, the red orange at the top, that is the North Chelmsford Water District. And so you can see the division. The blue down on the right, that is the East Chelmsford Water District. The white, as you can see, is that's the River Neck. And the best way I've ever been able to describe it is there's kind of a squiggly pressure zone line that runs from Drum Hill south to Carlisle. And so that's the division of the two systems. And the brown there is what is in Crooked Spring. So going to the next slide. The regulatory authorities that we answer to are both EPA and the Massachusetts Department of Environmental Protection, especially on PFAS. The EPA has a current health advisory of 70 parts per trillion for PFOA and PFOS. Now keep in mind, that's only two of these polyfluorinated compounds. There is somewhere on the order of 4 to as much as 6,000 of these individual compounds in this family of compounds. EPA's main job with drinking water is to set federal limits and levels and be the enforcer of those. A lot of states just use the EPA as their enforcement, and EPA has what is called primacy in those states. And then there's a group of probably 20 to 30 states that took on the primacy of themselves and have some sort of environmental protection agency of their own. And that would be, for us, Massachusetts Environmental Protection, Department of Environmental Protection, excuse me. The PFAS regulatory timeline from the EPA starts out in 2002. The regulations of PFAS began with what is called 2 significant new use rules. 2003, the EPA negotiated with the PFAS manufacturers, primarily 3M and DuPont, to produce the Memorandum of Understanding, which detailed their plans to stop using these 2 substances. In 2006, EPA invited 8 other major PFAS producers to join the PFOA stewardship program, which pledged to reduce 95% of their facilities' production of PFOA emissions by 2010. 2009, the EPA regulation of PFAS through the Safe Water Drinking Act, SDWA, began when the EPA released provisional health advisories for PFAS and PFOA. Again, now, these are only 2 of the compounds that we're worried about. 2013, UCMR3 monitored the possible PFAS in drinking water. Now, UCMR3 is an EPA program every 3 to 5 years comes out, and it's the unregulated contaminant monitoring rule. And there are thousands on thousands of these types of contaminants, whether they be biological, man-made, or what have you. And they come up with a list of about 30. And usually it's the first time these methods are used, and you run, all the utilities in the country have to do it depending on their size. And we always have to. In 2013, 15, we did partake in this. And we actually did not detect any. Primarily, the detections were in and around military bases, Air Force, airports, and anywhere there was firefighting training. And the main direction this sent them in was looking at the AAA firefighting foam. And that was the belief that that's where the primary or the problematic contamination was. The problem with this program is it's usually the very first time these analytical methods are used, and the detection limits are a lot higher than you probably would like. Going forward in 2016, EPA issued a lifetime drinking water health advisory of 70 parts per trillion for PFOS and PFOA. Now keep in mind, health advisories are not enforceable standards. You can't really base treatment plants or any sort of significant rules on these health advisory limits. 2019, EPA released their PFAS action plan and documented their intended, a document intended to outline the steps EPA was taking to protect public health by addressing PFAS. And that's kind of where we are right now. They are looking at it. I think the Senate just released their final report, and then it's up to EPA to come up with how to meet their plan. MassDEP has a regulatory authority and primacy over drinking water. And what that means is they're the sole controller of it. They can't make anything less than the federal government, but they can definitely make things stricter. Mass regulation is termed PFAS 6. And what that means, it regulates this as a family of compounds as a group where any combination of the 6 listed individual compounds must be less than 20 parts per trillion, which is the listed maximum contamination limit, or MCL. Most states use the EPA health advisory to set their state standards, their regulatory level, while another 20 states with drinking water primacy set their own, with Mass being one of them. Beginning in 2021, MassDEP set the 20 parts per trillion as the mass contamination limit. And it's based on a quarterly average, meaning not one single detection over 20, meaning a single detection over 20 is not a violation. It just means the 3 months average. If the 3 months average is higher than 20, that's what equals a violation. Now the 6 PFAS compounds, and I'm just going to give you the abbreviation because you don't want to hear me butcher these names, but PFOS, PFOA, PFHXS, PFNA, PFHPA, and PFDA. Now, the difference is the number of carbon and fluorine bonds on these. The older ones have a lot more, upwards of 12 or more of these bonds. And as you go down, they get smaller. The more of these bonds, the longer they live. And to give you an idea, when we're talking parts per trillion, I really wanna, this was the best visual I could get on how small 1 part per trillion is. It's 1 ink drop in 20 Olympic swimming pools. So the levels we're talking about are exceedingly small, as are the detection limits. So like I said, this was the best visual representation I could get of it, and I hope you appreciate it. PFAS are a group of manufactured chemicals that have been used in industry and consumer products since the 1940s. Because of their useful properties, there are thousands of different PFAS, and some have been more widely used and studied than others. Some of the most commonly used PFAS chemicals like PFOS and PFOA have long half-lives, earning them the moniker of forever chemicals. Biomonitoring studies by the Federal Centers of Disease Control and Prevention show that the blood of nearly all Americans is contaminated with PFAS, meaning, from what I understand, not one single person in the United States that they have tested has not tested positive for PFAS in their blood. The stability of these PFAS means they are extremely persistent in our bodies and in the environment. They bioaccumulate. Because they don't break down naturally, they build up in our bodies. Some PFAS can last as long as 8 years in our bodies, leading to an accumulation over time. Some of the most studied chemicals, PFOA and PFOS, will not naturally degrade in the environment. The strength of these carbon-fluorine bonds, which make it such a desirable compound, also make it as difficult contaminant to remove, treat, or destroy. down on the right, you can see that this is, I believe, PFOA, and it has the number of carbons and fluorines attached to it. One of the things they'll do to look to see if some sort of product has PFAS in it is they will look and break down and look for fluorine. As you can see, it starts at PFAS and it gives you kind of the family tree of these compounds. What everyday items contain PFAS? First thing is why do they? Well, it seemed like a good idea at the time. They are really, really good compounds to repel dirt, grease, water, and stains. They just really, what's made them so useful, non-stick cooking and things like that. But at the time, it did seem like a good idea. Now, this is what we're looking at. Everyday items, food wrappers, coating paper and packaging, the firefighting foam, water and stain resistant coatings on furniture, carpeting, bedding, clothes, herbicides and pesticides, paint, varnishes, inks and dyes, waterproof clothing, cosmetics, sunscreen, shampoo, personal care products, non-stick cookware. And to talk to a little bit about the depth of this, I take the samples for the district. That's part of my job. When I take the samples, I cannot use personal care products, commercially available ones, 48 hours prior to sampling, nor can I use my normal work attire because it is water resistant. So, those are the precautions I go through so that I don't make sure we don't have a false positive. University of Notre Dame released a study last summer on cosmetics sold in the United States and Canada. They found, I believe, about 65% of all cosmetics sold had a percent level PFAS in them. And what that means, so that you understand it in terms of parts per trillion, 1% in something of a solid nature is 10,000 parts per million. So if you have something that's 0.5%, it doesn't sound like a lot, but that's 5,000 parts per million. Now multiply that by 6 or add 6 zeros on the end, and that's how many parts per trillion there is. So if you look, a raincoat was tested and it found to have 220.5 nanograms per gram of PFAS in it. Now 1 nanogram per gram is equal to 1,000 parts per trillion. So at 0.2, it had 220,000, over 220,000 parts per trillion in it. And so that's kind of, what we're looking at. Anyone I've talked to about this, there's a couple things I've said to them. One is this isn't really anybody's fault. We have probably 2 main culprits or anyone that is similar to them, and that would be DuPont and 3M, because they probably did know about this for a very long time. But we own a certain part of this because of our society. We like things quick and easy, and it led us to the point that we're in with this sort of thing. Let's see, there we go. Now, how are we exposed? These are some ways. Working in occupations such as firefighting and chemical manufacturing or processing. I have to say, and it breaks my heart to say this, some of the people most vulnerable to this are firefighters. Their turnout gear is in the really high percent levels. And to be honest with you, I don't know the level, but the minute water hits these compounds, they become very mobile in it. And the minute it hits out their turnout gear, turns to mist, and they breathe it in, or they get some in their mouth, they're being exposed to these chemicals. Unfortunately for us, drinking water that's contaminated with PFAS is an issue. Eating foods that may contain PFAS, including fish. One of the things you should realize too is the state of Maine issued a health advisory last fall on harvested deer meat. The deer meat itself came up with measurable amounts of PFAS. Excuse me, I hit that by accident. Let me go back one. I apologize. The deer meat had measurable amounts of PFAS in it, so they issued a health advisory. Swallowing contaminated soil or dust. That's probably going to be more so depending on what industry you work in. Breathing air contaminated with PFAS. It needs to be a mist. That's kind of misleading. It's not actually, to be actually in the air, it would have to be in a mist or a wet mist. Using products made with PFAS that are packaged in materials containing PFAS. There was a study on food wrappers that the FDA just released. The main exposure route for teenagers right now are microwave popcorn, delivery pizza, and Chinese food. Something else you should consider is pets. Pet food containers, whether they be canned or bagged, are made so that the oils don't saturate or that none of the food sticks to the interior of that. And that is solely because of PFAS, and it does absorb into those foods. And that's some of the things that we're dealing with the pets. Now, how do we limit our exposure? I would say the best way is to favor companies that have pledged to remove these chemicals. And don't be fooled by environmental friendly claims. They don't guarantee a product is PFAS free. I would say the same about filters. At the end of the presentation, there will be a link to the Chelmsford Water District website and the PFAS tab. That, I got to tell you, has a lot of really good information. It is well verified and vetted, and it's to be trusted. In there is a link to filters that have been certified by what is called the two agencies that certify consumer products to do what they say they do, and they've been certified. I'll caution you though, they've only been certified down to the 70 parts per trillion of the federal limit. Now, where we run at or below 20, do I think there is removal and is it safe? Yes. It just, I couldn't guarantee it because of that limitation. Avoid using waterproof or long-lasting cosmetics. Looking for PFAS-free products in cookware, pet foods, furniture, carpeting, clothing. As I said, avoid clothing and other products laced with PFAS. And I got to tell you, with industry and businesses, the biggest way you can impact and get rid of this out of our lives is to vote with your checkbook. Buy things that are PFAS-free, and it does bring about a change. Reach out to your congressional representatives and senators and support bipartisan bills. One of them is Keep Food Containers Safe from PFAS Act. Both Democrats and Republicans are solely behind this. Support your local, state, and federal legislative initiatives to help pay for treatment or remediation of PFAS. This isn't something easily done to take care of, whether to get rid of it out of a contamination site or to get it out of a drinking water. And then what do you do with it afterwards? In the best way, one of the other things I've told everybody is, I don't think anything I've told anybody is actually going to make them feel better, but it will make you better informed and you'll make better decisions. So the best way is to become better informed so you can make these better decisions. But be careful where you get the sources from. There are some really bad information out there, and really try and stay to well-vetted sources. Now, is Chelmsford alone in this? The simple answer is no, not in Mass nor in the country. Give you an idea, and this is the map from 2018 of PFAS detections in the ongoing response. So you can see there were a few, Air, Hudson, Westover, in and around Westover, in and around Fort Devens, Hanscom, and a few other places that had fire training academies. Now you look to the map in 2021. The red is the number of communities that have detections over 20.5 parts per trillion. The yellow is they have PFAS there, but it is below the 20.5. And the green are the ones that have tested and have been undetected. Now, the white, they just haven't detected. It's probably because they don't have a municipal system and they're all private wells and they haven't tested them yet. So we don't have reports on them. But it gives you a stark difference in the awareness of this and how prevalent it is in our society. Now, how is it affecting the Chelmsford Water District and what are we doing? Well, to start off with, everyone knows about the third quarter MCL violation. And we were mandated to achieve a long-term solution. For us, that equals additional treatment at the Crooked Spring Water Treatment Plant. But to give you a little bit of background on this, we actually partook in the free PFAS testing program that DEP had. So we tested probably about a year before we were required to. Now, there are risks to that because if you do find it, it means the spotlight's on you. The benefits, though, are that you're first in line for help. And that's kind of where we are with that. We tested for it. Those detections determined the level of sampling we did. The sampling requires us to sample monthly. And we have done that since, I want to say January of 2021 is when we started that. Our problem seems to be seasonal. We have a problem with third quarter where the levels do start to rise in July, August, and September, and then come back down. The current treatment at our two main plants, Crooked Spring and River Neck Road, are what are called green sand filtration and chemical treatment. Now, this picture is of an aeration tower that's about 15 feet in diameter and about 25 feet tall. Water comes in, is dropped from the top and pushed, and air is pushed from the bottom up. And it does several things. It removes naturally occurring odors. It starts the oxidation process and some other things that we need to do. It actually starts the adjustment of pH so that we use less chemicals in treating for pH. When it leaves there, now the wells have been mixed before they get there. So they come into a raw water clear well and they go through the aeration tower. The next stage is it goes to green sand. Now, green sand is a type of carbon. It's just not activated carbon, so it doesn't treat PFAS or compounds like PFAS. The green sand is on the top, and then there's different grades of gravel in these filters. Now, these filters are about 15 feet tall and 35 feet long, and they're what are called horizontal filters. So the water comes in, and you don't need the contact time with the material to get the job done. So as the water enters the top, it's hit with two chemicals. Sodium hypochlorite and potassium permanganate. They're very strong oxidizers. Now, sodium hypochlorite, if you really want to sound bright to your friends, it's just a scientific name for bleach or chlorine. It is dosed so it does the oxidation of iron and manganese. We also dose it as a disinfectant, so we have a measurable chlorine residual leaving the plant. And it has to be a very, very specific amount because we are what are called a groundwater certified facility. That means all of our facilities remove 99.99% of all potential biological contaminants. To give you an idea, that's our chemical room. Now you have all the different chemicals. You have the bulk tanks, the day tanks, and the pumps. Now those pumps are all controlled by a control system, and there are multiple alarms. So if anything goes wrong, if there's a leak, if it pumps too fast, if the level goes up because demand goes down, it all automatically controls it and lets us know. So that kind of gives you an idea of what we do on a daily basis at the treatment plants. Now, this is Crooked Spring. Now, this is an aerial vision of Crooked Spring, the building, the water treatment plant, the backwash lagoons, the solar array. Meadowbrook 3 on the colored picture is in the top left-hand corner. That's our main pump station. That also is where it seems to be our main problem with PFAS. Unfortunately for us, it's not something we can just shut off and then still maintain. It produces the majority of the water for Crooked Spring and the district, if you look at the averages. So it's something that we have to kind of live with and get it fixed so that we can continue operating as we should. The proposed area for the new treatment is the outlined white shaded area there on the right. Basically, we're not going to change any of the treatment inside. The water leaves the plant out of what's called a pipe gallery, and it's probably a 24-inch pipe that comes out the plant. The idea is to cut that before the potassium hydroxide, and that's the other thing about the chemical, and I apologize for that, I'll go back to that. Just before we leave the plant, we hit it with potassium hydroxide. So the pH of the raw water is probably anywhere from 5.6 to 5.8. By aerating it, probably goes up to about 6.2, 6.3. And when it leaves the plant, after we dose it with the potassium hydroxide, it's in the high 7s to 8.0 pH when it leaves the plant. By the time it gets to your residence, it settles out at a very stable 7.5, which means the water is basically neutral and non-corrosive. So what we're going to do, or the plan is to cut that before the potassium hydroxide addition where it enters the pipe, and basically put elbows and, for a lack of a better term, cut and play. So you're going to cut it in, the pipe will go out to the new treatment zone, go through the filters that are out there, come back, elbow back in, and we will redose with chlorine because there will be some reduction of the chlorine, and the potassium hydroxide will be added, and then it'll enter into the system like it normally has. The idea is so that we have minimal impact on the way the treatment system works now and minimal impact to you. The difference is these filters are vertical because we need long contact time with them. And so that you also know, last summer we received a $250,000 grant from the state, and we did the pilot study. And this is the study that determines what media works best for you under your circumstances. We tested 3 different types of things. We tested GAC, which is granular activated carbon. It is the most common form of treatment for PFAS. Then we also did 2 ionic resins, one gel-based and one ceramic. The GAC worked. However, it didn't break out where the PFAS made it through the filter, happened far too quickly. We would have to change it out, and it would just make it financially unfeasible to do. The 2 resins work very, very similar, but we kind of veered towards the ceramic because it allows us to push a little bit of chlorine through it and keep it disinfected. The gel resins have a tendency to get foul, where a bacteria gets in there, there's nothing to kill it. You're collecting all these things. It's a great place for it to grow. Just so you know what they look like in real life, this is the ionic resin filters at the Air Water Department Grove Pond Treatment Plant. So what are we doing else? We're pursuing state funding through the Drinking Water State Revolving Fund. PFAS treatment is only going to be funded through this, and they're basically bonds, so we would have to bond it out, but it will be 0% interest and with some level of principal forgiveness. How much, we don't know yet. It's a lot is it going to depend on the federal infrastructure finance bill when that gets released by Congress. The money will come from the federal government and go to the state revolving fund, and that's how it'll be issued. So we would be going probably, so the way it works right now, the pilot study is finished. We ran it until December. It's told us what we need to look for. The final engineering and design process has started. That should be completed by August, which puts us in line to apply for what is the state revolving fund. The abbreviation is SRF. We should be able to apply for SRF August through October. Then you don't hear until January or February if you make what is called their intended use plan. If you're on that, you basically then go to your residence and you get approval to bond it, and you submit that to SRF. It becomes finalized at the beginning of the new fiscal year, and the idea is to go out to bid for construction by the end of the summer of 2023, and usually that bid would go out and come back by end of August, beginning of September, and with construction to start thereafter. You got to understand, though, that this is, like I said, we're not in this alone. The filter vessels, the backlog for it is upwards of 52 to 54 weeks to get them delivered right now. And that has nothing to do with a supply chain issue. That is how many people are looking for these filter vessels. We're one of the first utilities to have joined with other mass utilities and communities as a complainant in the class action lawsuit against DuPont, 3M, and some other companies. I will say, and in talking to the lawyer, the lead lawyer, this seems to get settled a lot sooner than a lot of other ones, because they see the amount of evidence building up, they see the extent of the problem. So we've been led to believe this is a matter of a couple to a few years instead of decades. So that is something that hopefully funding would come through for us. And where we were one of the first, that puts us in a good position for help coming from the lawsuit. And that's my end of my presentation. Again, I'm Todd Melanson. I'm kind of a big, ugly, bald dude. My email is tmelanson@chelmsfordpotter.com. The office phone is 978-256-2931. The website is listed down there as well with the PFAS tab listed. I really recommend you go in there and getting the good information. And I always appreciate feedback. So with that, I will take any questions you guys got.
Thank you so much, Todd. That was wonderful. So Tricia would like to know, what causes the PFAS amounts to vary in the testing?
That is the million-dollar question. I haven't figured that out. Our levels are primarily what we call environmental background. The same similar levels exist in Stony Brook and in Beaverbrook. Where it's coming from, I don't know. Some of the communities further west are finding the contamination isn't coming from one like industrial source, but from really compact amounts of septic systems. But for us, I wish I knew. It would be a lot easier for me to do it. It makes my job a lot more difficult. So I look, I'm attached to the planning board. I get all their emails with agendas on it. I look at the projects. I look where they are in relation to our wells. I go to the Bureau of Wayside Cleanup, make their what are called RTN numbers. So each contamination site gets this number. I look it up if it's in the area and find out what contaminants, and I'm looking for PFAS and stuff like that. So like I said, I have no idea. Listen, my job in the military was military intelligence. I always look for a reason somewhere, somehow. I haven't found a legitimate one to be able to.
Can you talk about, like you were mentioning to me earlier about how early in the research we are, like how we're not quite done with the studies that they're doing?
No, we everything is based on a potential threat. Right. One of the things you should realize too is PFAS, when you're given a contamination and a max contamination limit, it's given a certain tier. So tier 1 is called an imminent threat to your health. We have 24 hours to notify you. That's boil orders. I don't like talking about them. They make me nervous.
Like Hurricane Katrina or something like that would have been.
No. Actually, that's an emergency response impact. What I'm talking about is when we detect something bacteriologically, arsenic, things like that, something that will have an immediate impact on your health, that if you consumed it, you would get sick or have something worse happen. PFAS is in what is called tier 2. And we have, that's a potential chronic impact. And you go from imminent threat to chronic impact. And that's based over a lifetime exposure, and we have 30 days to notify you. It just to kind of give you a level. I mean, even in the notice that went out about the violation, it says for the normal person, it's okay to occasionally consume over 20. Is it optimal? Am I happy about it? No. You won't find a more disgruntled group of people than water operators, because we take pride in being able to say the water we give you is safe. Right. It's kind of a kick in the pants, to be honest with you, to have this, find this stuff. I mean, the method to see this low didn't exist until 2 or 3 years ago. So, it's what we have to deal with. We kind of have ourselves to blame to a certain degree. Definitely 3M and DuPont are the main culprits and I would say villains in this story. But we do bear a certain amount of responsibility for it, unknowing as it was. But you know, we're well on the way to being able to try and fix it and stuff like that.
Peter, oh, sorry. Peter, hang on one second. Let me just find Peter's question. How quickly will we be notified if there is a quarterly exceedance?
Peter, that's a really good question. One thing I'll ask you to do is all of my quarterly updates are on the website in that PFAS tab. They're in chronological order. So let's go over how it's done. I sample the PFAS. Now, there are only a few labs that do this right now. There are more coming online. I'd rather deal with someone that's been doing it for a while and has a good reputation. But the average turnaround time for the analysis is anywhere from 4 to 6 weeks. Then when you get the results, there's a bunch of things that are unlike any other contaminant I've seen. No other contaminant has a subgroup of concern like PFAS does, and that would be pregnant women, breastfeeding women, children under the age of 6, and people immunocompromised. I don't know of another contaminant that has that, nor have I ever seen a contaminant that when the report is released, the QC can fail and they can still release the report and they just qualify the data. Well, that required DEP to create a QC department. So when the report is released, it then goes to DEP and they're getting more and more of these reports and they have to do a QC on it. I've actually worked with the lab. I told them that until I get treatment, every sample I've had has had PFAS in it, and to run the field blanks alongside it. Because right now what they do is they run the sample. If it doesn't have PFAS in it, they don't have to run the field blank. It saves you a little bit of money, but it also lengthens the time if they do detect it. Our turnaround time right now is running about 10 business days. And then I got to give credit to Northeast region of DEP. That's who we deal with. They've done a very good job. And I probably get it in another, I want to say, week to 10 business days. So that's the time frame. And I can't release any information until it's done. So April, to be honest with you, Crooked Spring came in at right around 10 or 11. So I have April, May, June. I take them the beginning of the month. I was getting the beginning of the next month. Now I'm getting it before the end of the month. So I hope to have, once I get approval from DEP, to have them out before the end of the last month of each quarter, if not the first week of the next month. And I hope that answers Peter's question.
Is the water from River Neck and Crooked Spring mixed together before entering the homes?
No, not really. There is a little bit in South Chelmsford, but for the most part, the water is gated off. If we didn't, the pressures would, like I said, push those. That black line going down the center of the map are closed gates so that each is pressure segregated. The only difference is in South Chelmsford, because it is so far from Crooked Spring, we do have a quantity issue. There's only 2 ways that gets across 495. It goes under the bridge on Hunt Road, and there is a 6-inch water main that goes under 495 that comes out on Chamberlain. Those are the only 2 ways it gets down into South Chelmsford. So what we did, there are 2 booster stations, one on Fay Street that takes water from River Neck Road and pushes it down Acton. And then there is a booster station between the 2 storage tanks on Robin Hill. The smaller one on Hillside is on the River Neck side, and the larger one on Summit is on Crooked. We have a booster station that pushes from the smaller to the large. So there is some mixing, but can I tell you how much? Not really. But I do know that there is some that goes on. So South Chelmsford may be a little bit less, but is there, beyond that, there is no crossing of the 2 waters.
And then Jewett would like to know, John and Max Jewett would like to know, what are the negative health effects of PFAS?
That gets into the studies. A lot of the studies aren't completed yet. And we're based on theoretical calculations of risk. What they've associated with is certain effects to the thyroid, certain developmental effects, because it does affect the thyroid. There is some autoimmune concerns about it. And they have talked about links to cancer, but I haven't seen any definitive reports on that, on what type of cancers or if it is. A lot of times with these type of contaminants, if they don't know, they automatically say it's linked to cancer. And until I find out differently, you know, we just have to go with what they're telling us. And those are the main links to it.
And then how do we know if the bottled water we're buying is PFAS free? You mentioned Maine. I mean, Poland Springs.
So I will say the best way to do it, don't go by the label. On the label, it should tell you who bottled it. Research that bottle company, find their website. I'm not advertising for Poland Springs. They just have the easily accessible data. If you go Google Poland Springs water quality results, it will come up. They have tested for it, and their water comes up ND. Now, I don't know how often they test it. I don't know, you know, like I said, I don't know how often they test it, if they test it once. But here's the difference. My drinking water regulations require me to have a detection limit of 2 parts per trillion per compound. The bottled water regs are different. They are allowed 5 parts per trillion per compound. Now, is there a big difference? No. And do I think below 5 parts per trillion is safe? Yes. But there is a difference. So there's 3 parts per trillion. If you had that times 6 is 18 parts per trillion, you're at 20. So just keep that in mind. One thing I would say is stay away from any plastic container that has been strengthened to be reusable or durable over the long term. The way they do that is they fluorinate the plastic. And the way we know that is last spring, there was a big concern about the mosquito spreading PFAS. The chemical was tested at the point of spraying, and it did test positive for PFAS. They did a study and an investigation on it, and at the manufacturing plant, there was no PFAS in the product. However, if it was stored in the plastic containers that had been fluorinated, which means PFAS was added to the plastic, the PFAS was leaching out of the plastic and into the product. So I have a feeling that similar things happen with water. So if it was me, I probably would stay to the smaller containers like the 1 gallon and 3 gallon. But big thing is do your research. I will be honest with you, if there's any trouble finding water quality results or you call somebody and they hem and haw about it, do yourself a favor, just walk away. It's not worth your time. The results should be readily and easily available. And if they're not, it's not worth your time.
So just on that, so do you recommend, because I know there was like a question about BPAs, which are the chemicals in plastic bottles, some like baby bottles and things like that. So are reusable plastic bottles okay? I mean, the ones that you buy, like the hardened plastic, is that, would you recommend glass bottles?
I don't know.
Yeah.
And I'm only making a correlation between the mosquito. You know, a lot of this is we're probably going to find out as we go along, to be quite honest with you.
Okay.
While we're talking about things, I did mention filters. There's 2 things I want to mention about filters is reverse osmosis does work. Also, always, I would go and double check the list of certified filters, because it doesn't really matter what a company says. If they say that it removes it, unless it's been certified, there's no way to verify that it does. Okay. But keep in mind, I know reverse osmosis does, but keep in mind this: reverse osmosis rejects 8 to 10 gallons of water for every 1 it produces, and in that reject water will be PFAS. That will go to the sewer. The next ones that get regulated are going to be the wastewater treatment plants. And right now, there are no ways to treat the chemistries of wastewater to remove PFAS. So they will be asked to do best efforts to reduce PFAS in their effluent. The only way to do that is to reduce the amount coming in from the communities they serve. And my fear is if you spend the money putting in a reverse osmosis system, you may be asked to remove it so that you can reduce the amount that's in the sewer. The carbon filters, and I don't recommend people get filters on a regular basis, to be quite honest with you, because in my experience, residents get very complacent. They get used to them. We all do. I'm as guilty as anybody else. I forgot to, you know what? I forgot to buy the filter. I'll get it next week. I'll get it next week. With normal filters, that's not a big deal. You might lose a little bit of pressure, maybe a little bit of volume. But when we're talking about things like PFAS, they build up in these filters. And once they get saturated, they give off concentrated amounts of PFAS. So my recommendation would be, if you do put a filter in, remain diligent, change it when it says, don't push it. And that would be my advice. But also keep in mind, we're working very diligently to solve that problem and have zero PFAS in the drinking water with the filtration. The other problem with these is when we dispose of them. We're homeowners. I'm a homeowner. Most of the stuff mine goes in the trash. The trash goes to a landfill. Now, my biggest thing is I don't mind hard fights. I don't mind hard work. If I'm going to do something, I always like to try and do it right. And if we're going to solve this problem, we really need to stop the cycle of it getting into the environment. So the other concern I have with filters is, what do we do with them after they're saturated? Do we just throw them away like we do everything else? They go into a landfill, it ends up in the leachate, and then we have an additional problem. So, you know, like I said before, nothing I'm going to say is going to make really anyone feel better, but you'll be better informed. We'll make better decisions, and I hope you understand the magnitude of the problem we face. And I hope we have your support in a lot of it. I have to say, I got to commend the leadership of the district. It was a real risk to go out in front and be one of the very first to start testing, because the spotlight, when we found it, was on us. And it was more important for them to find out if we had a problem so that we could start working to fix it before the herd of people started looking for help. And for that, you know, the water commissioners of the district, I really, and the superintendent, Robert Delaney, and the new superintendent, Andy Reid, are always been behind that philosophy. And you know, it's something I have to commend it. I'm glad I work with them. I work with an exceptional team of people. I work with a group in an industry of exceptional people that take a lot of pride in what they do. And I'm proud to be one of them, to be honest with you.
That's amazing, Todd. Thank you so much. I really appreciate all of your time tonight. Oh, we did have one other question. Do you have time for another question?
Yes, ma'am.
Are PFAS listed as ingredients in sunscreen and other items? Are PFAS listed as ingredients in sunscreen and other items?
What I would say is look for anything that is a polymer additive. If they don't describe it, you got to kind of assume it's PFAS. What you can do is go to the manufacturer and ask them if there is PFAS in it. If it's water resistant, you know, some of them are just lotions that will be a sunblock. But if they're water resistant, more than likely they're going to have PFAS in it. I think you're going to have to balance the need to protect yourself from the harmful effects from the sun versus potential impact on PFAS or from PFAS. It's not an easy decision to make. It is very ubiquitous in our society right now. Who would have thought dental floss would be something we need to be scared of? So it's not an easy problem to talk to, and I would really try and go to the manufacturer and see if it is. But if it says water resistant, I'm almost 100% sure it'll have PFAS in it, unfortunately.
That was such a great presentation. And I think that everyone really appreciates all the information that you gave us tonight, Todd. I would invite anyone who has any other questions. I'm just reading another one. All right, so I guess we have time for just a couple more questions, and then we will probably close it out. But is that okay with you?
Yeah, I'm here. I'll
yeah.
make myself available as long as I need to.
For planning purposes, what is the expected year at which the PFAS treatment at Crooked Spring will go online?
So if everything goes according to plan, our annual meeting is tonight, actually. So they're doing one of the articles was for the engineering and design. Then the next stage will be, so that will, if that passes, the engineering design will start July 1st, probably finish by mid-August, I would say. That gives us time to put an SRF application in by the due date of October. And then it's a waiting game. And this is one of the times having multiple state reps is a plus. I like having them. Having more voices speak for us is better. We will advocate for the district to get included in the SRF intended use plan. That will come out in January or February of next year. So we're looking at 2023. We will then go to the next annual meeting and appropriate the money that's been suggested for the treatment plant. If that passes annual meeting, the construction contract bid goes out July 1st. That will probably take until, again, mid-August to get decided upon. And once that contract's awarded, we're off and running.
That's mid-August of 2023.
And so my hope is by the end of 2024 or the big spring of 2025 to have the treatment plant up and running.
Wow.
So, I mean, it sounds like a long time, but I will tell you in terms of municipal water, this is light speed. It really and truly is. And so, you know, one of the biggest things I have to say is we really will look to the residents for their support when we go to do this, when we go funding and stuff like this. As a district, you know, districts are kind of the model because we're a separate we are a municipal entity. We're separate from the town. Our sole responsibility is drinking water. Our sole funding is the money we take in from the water receipts. We don't get any state, local tax dollars and stuff. One of the minuses is with things like the MVP grant program and things like ARPA and stuff, we have to go to the town and ask for an allotment. And, you know, their priorities are a little bit different than ours sometimes and things like that. And a lot of the time, you know, we don't end up having availability of those resources. So it is really going to come down to our ability to get on the end our SRF intended use plan. We will keep you updated on that. And, you know, what I would say is once we put in that application, whatever representatives we have, if you ring their bell and say, we need this help beyond me ringing their doorbell, the more voices that are speaking for us, the better. And I would ask for your support in that as well.
Thank you so much, Todd. I think if you have any other questions for Todd, his information, his email address and his phone number is right there on the slide. I will also forward that to everybody with this recording tomorrow. And I really appreciate everyone coming online with us for this presentation. And Todd, I really appreciate your time tonight. Thank you so much for explaining this really, really complicated issue to us.
No, it is. It's complicated for us. The one question about where it came from is, for me, a great question because I would have thought I would have been able to find it and I haven't. So I appreciate everyone's questions. They were really great questions. And I got to thank the Chelmsford Library. I really appreciate the opportunity to be able to come out and explain this and talk to people about it. It's a little bit easier doing it this way than individual phone calls. So I really appreciate it. And thank you very much for the opportunity.
Oh, thank you so much. Thank you so much, everyone, and good night.
Good night, everyone. Thank you very much. And thanks for any help you give us. I appreciate it.